Hi ROS developers, and welcome to this ROS project series. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, with autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning in just a few videos. I'm Miguel Ángel Rodriguez, and today you will learn how to make this puppy, this hopper robot, start to learn by itself, to at least to stand. That's the objective. If we can make it walk, that would be amazing. And we are going to use for that various systems along this video series. In this videos that we are going to do now, we are going to use Gym. So if you don't know what Gym is, I don't know in what planet are you living. So it's basically a platform that allows you to compare different learning algorithms with the same environment. So for example, you're seeing here like I don't know, this basic control system. You can compare it, your algorithm, with another one that has created another learning algorithm in the same environment. So you're working in the same conditions and you can compare them. So if you want to learn more step by step how to use OpenAI Gym, I highly recommend you that you go to Robotics Academy, where we have loads of courses, but one in particular is about OpenAI Gym 101. So here you will learn step by step how to make this work. In this video series, I'll try to give all the details, but it's really dense, and I highly recommend you that you do it. If you don't feel comfortable, try this course and get a feeling of how things work, and then you'll get this next videos much easier. So let's get started. So the first things first, we finished our last video having this robot basically working and moving. Okay. After making some tests and throughout the OpenAI learning system, I detected some minor errors, or maybe I made some updates that I would like to share with you. By the way, all the code that we are going to generate in this videos, it's in the Git. If you've seen the other videos, you'll have the Git with the code that we generate here, so don't worry. But yeah, that's it. So let's have a look first this, because it's quite important. So I think I have it already open here. Yeah. So if you go to the ROS Development Studio IDE, you can see our my-legged robot's description. So basically, I made some changes to it. So I have my version here, which is, so if you compare it with the old one, there you go. Okay, now we're on the same page. So you can see that there are some stuff that it's different. Why? Well, basically, it's generated by two things. One is when you have this system and you have to learn, you have to iterate. This means that you have to reset the simulation time and time and time again. What's the problem with that? Well, basically, one of the problems that you have is the TFs. TFs give a lot of problems when you reset the simulation, because the time resets to 0, and TFs don't like that at all, and they give a lot of problems with that. So one of the things that it's really important is the fact that that gives a lot of problems is the update rate. So you have to put a maximum update rate. So basically leave the system and set its own update rate so that it minimizes the problems with that. That's one. That's why it's commented in the new version. This way it will publish as fast as it can possibly publish and adapt, and this will generate less problems. The other thing is that I modified the inertias and the weights, just because the weights in the old one were all the parts weighed the same, which is highly unrealistic. And in this one, I basically gave more weight to the base, as you see. Then the hip assembly was much smaller, and also I adapted the inertias for that. So I got, based on the weight and the dimensions of the box, the geometry or the bounding box in case of the meshes. So I explained that in the previous video, so I won't explain that anymore, but basically I adapted all that. So for the moment we are going to use this the Legged Sims Robot Sims version, and I'll post this code to the original Git, okay? So don't worry about that. But basically I wanted to comment on that. So once we get that, let's get into the interesting part of the video. So basically we have this fantastic simulation that it's here, okay? Legged Robot Sims, we launch it and we have this, okay? Yeah, clear. But now we wanted to learn. So for that, we're going to create this Hopper training package. So let's do it. So let's have a look. Source. Locomotion. Okay. And then I'm going to catkin create my Hopper training, okay, with ROS as dependencies. Okay, fair enough. Now let's see, we have it here. There we go. So we don't have anything, so we'll go step by step doing this and see what we can do, okay? So first things first. The first thing that we have to do, let me just close this. Okay. Okay, now the first thing that we have to do is a launch, like always. So let's get folder done, launch. Okay, and here we're going to copy this main launch, copy, and we're going to paste it. Okay, perfect. So inside here we have two things. We are launching this script, learning script, that we will talk about in a minute, which is basically the learning algorithm. So it's the one that resets the simulation, tries different policies, and stores all the learning, basically. And here we are loading some parameters into the ROS param server. These params are used for learning. So as you can see, it's called Qlearn. That's because we are going to use the Qlearn algorithm to learn, which is one of the most basic algorithms for reinforcement learning. So let's have a look. We are going to copy this config folder, copy, and Hopper training. Let's paste it. And let's have a look. So basically what we are loading here, it's a bunch of parameters that sets the learning parameters, and also some parameters that are related to when do we consider that the test has finished, when it has failed, when this kind of stuff, okay? And then the weights of the learning. We are going to learn all this. I'm introducing all these files. Okay, so we load this bunch of params. This is the only thing that you have to understand for the moment, and then we are launching this start training.py. So let's do this. Let me have a look. We don't have anything here, so let's have a look. Let's copy this file here, paste, and let's have a look. So this is the core. This is the Python script that makes all happen. So we import some modules. We import Gym, which is what we talked about, is this infrastructure that allows you to basically separate the simulations, the environment, from the algorithm that you're using for learning. So this allows you to use different learning algorithms with the same environment, and you have to code much less. Then you have our basic imports like time, numpy, random. So whoops, this one we're going to just repeat it. Then Qlearn, which is this one here. So let's copy that one, copy and paste. I'm not going to go very in depth with this module because it's a Qlearn implementation. There are loads of ways of doing this. Basically, is a script that makes Qlearn just transparent. So you use Qlearn in an easy way. Okay. What we're going to do also, well, let's leave it like that. Okay, then we have Qlearn, then we have Gym, the wrappers, then we have std messages, the float 64, because we are going to publish the rewards. Then we have ROS by and ROS package, nothing important here. And then we have monoped environment, which is the environment, the Gym environment that we have to define. Okay, so this is defined in this file here, which is monoped environment. That we'll go in depth, but I want to go step by step because it's a lot of steps and it might get a bit confusing. So just let me, like that, I think it's better. So what's this? Well, when we execute this, we initialize a node, which is called monoped Gym, and we set the log level to information, just because otherwise it's loads and loads of messages there printed. And here we start the environment. So the first thing that we do is load this monoped version 0 environment. And you say, okay, but where is this? How does this work? Let's have a look, just the first line of this monoped environment, okay? Just that one. So you see that this environment registers this environment with a name, which is called monoped version 0, which is exactly the same thing that we put in here. Okay, that's it. We'll talk about this later, but basically it's that. Okay, so we're loading this environment that we don't know what it is, but it's for so that you can understand it quickly, is we connect, it's a way of connect to the simulation. That's it. Okay, so we have this environment, then we start this publisher, which is rewards, because we want to see those rewards published in the topic so that we can paint them, or we can put them in our viz, or whatever we want. Okay, this is important. So here we're using ROSback to get the Hopper training, so we have to change this to my Hopper training because it's our package. So in this case it's my Hopper training. And then we say, okay, here, inside here, we create a folder which is called training results, and inside here we are going to put all the training results. Okay, then we set up some variables here, which is not important, but basically it's a numpy array, last time steps, just put it like that. Then here we are getting the parameters loaded by the launch file here. we're getting those parameters, which are, for example, alpha, gamma, epsilon, discount, and the number of episodes and the number of steps, which is here. Okay. This is related to Qlearn, which I won't go in depth unless you state it in the comments down below. Please, if you have any doubts and you want a video explaining all this, please leave it in the comments. But basically, this is important. So number of episodes and number of steps. Number of episodes is the number of episodes that you repeat, so the times that you repeat a sequence of learning. And after each episode, we will reset the simulation. Then we have the number of steps, which is in how we divide each episode. Yeah. As much, if you do a lot of steps, then it will be more precise, but it will be much slower, the learning, and computationally you need more power to go at the same rate, basically. Then we initialize this Qlearn object. As I said, if you want to know more about this, please leave it in the comments below. Basically, we create an object of Qlearn, okay, with a gamma, an epsilon, and so on. This is quite important, which is the action space. This is really important. This is the action space is something that it's defined in the environment, which I'm going to here. So the action space, you see that we define 6. 6 is the number of actions that this robot is able to do. In this case, 6 is increment and decrement for each of the 3 joints that we have. So it's basically turning left and right, go forwards and backwards, the leg, and then the third one is changing the angle of the knee, basically doing it bigger or smaller. Okay, these are the 6 actions. This is important to define in the environment. So this is the way we control the robot. We only are able to change those parameters, and based on that we have to stay upright. Yeah, so that's what we're getting here. Okay, then initial epsilon, start time, highest reward, we set it to 0, and then we start the training. Okay, this is a for loop, which it's repeated the number of episodes set. In this case, we have 100,000, yeah, 100K. And so we start the episode, accumulated reward, we set up the different variables, then we do the done. Done means it's the variable that says if this episode has finished. And an episode in OpenAI Gym basically finishes when something went wrong. In this case, this stops when the robot falls. And we have to define what does that mean, that the robot has fallen. We'll go in depth, but basically is that the height goes below a value. This means that it has fallen, or that the angle, the orientation of the base, it's more than 180 degrees. That basically is that it has fallen. Okay? This means, and the done is used for the training to see if the policy that it applied, it worked or not, and how well it worked. Yeah. So here we do the Qlearn epsilon, which is a greedy system. It's related to greedy, but then this is the important part, okay? When we start an episode, the first thing we have to do related to the simulation is reset the simulation. So put it like this. So you see, it's like that, okay? That's reset, and we'll define this when we go to the monoped environment. But basically it's having the simulation exactly as if we had launched it like from scratch. Okay, and now we do steps. Number of steps, which we have here 1000. This is the maximum number of steps. It doesn't mean that it will do 1000, okay? Because if the done gets, if it falls, basically, then it breaks, you see? So this is the maximum number of steps. So let's have a look. First thing is, we use the Qlearn to choose the action based on the state. The state is how the robot is. And the state is defined, you can define it as you want. We'll have that, we'll see that in a moment. But basically is, okay, my robot is upright, the distance from the desired point is 0, the height is like that, the pressure here is blah blah blah, and so on, okay? That's the state. In this case, the state is always a stringified version of the observations, that is called. The observations are the values, so distance, orientation, and so on that you can get here, data. And then the state is a stringified version. It's like giving a tag to each state. And these states in Qlearn must be this discrete. Otherwise, you'll have infinite number of tags, let's say, of states. So we'll see that also, but basically it's a stringified version. So it would be like, I don't know, like 0.4, 0.5, 0.3, 0.01, I don't know, and this as a string. And that would be a tag for a state. Then we would have another one and another one that define the different states that we can find the robot in. Okay. Okay. Once we have that, okay, you give it to the Qlearn and he says, okay, I'll calculate my stuff, and I'll say, okay, you have to do this. You have to, for example, I don't know, put the knee to 90 degrees. Okay. Then this action, which we print here, goes to the step, so to the environment, and says, okay, you have this action, execute this action in this step, and then it executes this. This means it unpauses the simulation, it moves the knee to 90 degrees, and then it pauses the simulation again and gets all the readings to generate the next state. And that's what you have here. So after the step, you get the next state, so the state that you are in after executing that action, the reward. So let's say based on that action, it moves to, I don't know, it falls, or it moves in a way that we are further from the state that we want to be. So that would be that the reward is much slower. Then done, for example, it could be that if the action is put the knee to 90 degrees, it makes the robot fall. So the done would be true. And then some extra information. Okay? This is one of the most important parts of this one. The step and the reset are the most important parts of this setting, environment, gym stuff. Okay, so we'll go in depth talking about that. Okay, once this is done, basically we have it all, because we have the reward generated from this action, that in our example here, it's moving the knee 90 degrees. Yeah, and then we put it in the accumulated reward, we update the highest reward, and then we learn. So we give the state, the reward, the action, the state, the state, say, let's say the previous state, the current state, the reward generated, and the action. And based on that, it updates the Qlearn matrix. Okay. Then we do the accumulated reward message and we publish it just to see it. And then we decide, okay, have we fallen? Has the robot fallen to the ground or not? If it hasn't, then we update the state. If it has, then we break. Yep. And then we see the last time steps. So this is what we're doing, is storing all the last time. So that the last time that we got it and it broke and it fall and we finished the episode basically. Yeah. And then we repeat this once and once again until we fall or the number of steps finish. Okay. And then we print some data like the episodes, the Qlearn alpha, and so on. It's not very important. It's just getting the rewards, the time that we finished. That's it. Okay. And that's quite it, basically. That's quite it, because once we have this, we just repeat and repeat this time and time again and see if it learns or not. Okay? Okay. So we'll finish for today here. And we'll continue how to set up the monoped environment in the next video. Okay? So see you in the next video.